Okay, 7O, circular motion. On the worksheet, you do number 1, 2, and 3. This is a chapter I enjoy a lot, and I think you guys will like it. It's going to get into planetary motion. I'm looking for something that I can spin around here, if I can find anything here around the room. Well, here's a cable that might work. It's not that great. I got to find something better than this, or I could tie something to it. Okay, anyway. Now, let me see where to start off. I'll talk about some of this in the lessons there, but a circular motion exists whenever an object is spinning in a round circular, or it could be an oval elliptical orbit spinning around. I guess I can use this to show you. This is just a cable, like a USB cable. But notice, I don't know. Yeah, if I put something on the end of it, it'll be a whole lot easier to see, wouldn't it? Is there anything I can tie to the end of that? Don't want to mess the cable up. Ha! I don't want anything too dangerous either. Actually, I do have something kind of funny. Here's a lid to like a water bottle. I don't know why. I think this water bottle doesn't work. Oh, this cable won't work either. It's not going to fit. Come on. This is how actually, you know what? I have something else. I have a name tag. Let me grab this. This is more boring, but it'll work. Okay, here's a name tag. So I'm going to spin this around and notice, okay, there it is. So it's going around in circular motion. Now it's better to have a little ball or something there. I can make the radius smaller like that. Oh, there it is, spinning around. What is true about an object when it's going in circular motion, spinning around? Think about that for a minute. There's a few things that are listed here. One, the direction is constantly changing. So see, remember, as it spins, here's what Newton said. Newton's law, and I know it's weird to use a name tag for that, but Newton's law says that an object will stay in motion, continuing the same direction at the same speed forever, until or unless a force acts on it. Well, it's not going in a straight line, it is curving. Why? Because a force is actually acting on it. And we'll get to that part in another lesson. But as it moves, it would go in a straight line, but it can't. Well, it can if it breaks, if the clip breaks off or unclips. It would go in a straight line, but notice it can't. It has to go in a circular motion, okay? Because the rope is putting a force on it there. All right. So the direction is constantly changing, and it says number 2. According to Newton's first law, an object in motion, I just said this, will continue at a constant speed, straight line, unless a force acts on it. So is the direction of the velocity changing? I put golf ball. I said imagine a golf ball is tied to a string. Okay, well, this is not a golf ball, but okay. If it were a golf ball, the same deal. You notice that it's moving in a circular motion. Okay, it's not going in a straight line. So its velocity is changing because the direction. Remember, velocity is the displacement over time. Remember how we said speed and velocity. Speed is just how fast you're going, but velocity is how fast and what direction. Well, see, you can be going at a constant speed as you move around. That's called uniform circular motion. Uniform circular motion. You could say constant circular motion means it is going at a constant speed, like on your clock, like the second hand of a clock going around. It is going at the same speed always. All right. However, its speed is constant, but the velocity is changing because velocity contains its speed with the direction. Its direction is, every moment, its direction is changing over and over. Okay, number 3, it says, according to Newton's second law, when a net force acts on the object will accelerate in the direction of the force applied. Okay, so it is accelerating also. That was the last thing to say. So if something is in uniform circular motion, these things are true. First of all, the speed is constant, but the direction is constantly changing. That means the velocity is constantly changing. It also means that there must be a force acting on it. Newton said, well, an object should keep going straight. Okay? Like, think about that with the moon. The moon is orbiting around the Earth, and the Earth around the sun for that matter, but the moon's going around the Earth. Now, is the moon following Newton's law? Well, because Newton said the moon would just keep moving at the same speed, constant, same speed, same direction until a force acts on it. But it's going around the Earth. That means there must be a force acting on it, and it does obey Newton because there's a force. The Earth's gravity is like a string keeping the moon in a circular path. Kind of neat. Okay. Well, anyway, then part 2, I wrote an object in uniform circular motion must be experiencing a force. And we'll talk more about that force later. It says here, I think we're going to see this on a later section, but what is the agent applying the force in each case? So a ball is attached to a string and it's swung in a horizontal circle at a constant speed. So if this were a ball, and just say if I were